Welcome everybody. My name is Anne Skoy and welcome to the Headwaters Science Center 3:30 afternoon show. And speaking of 3:30, I'm thinking today we're going to talk about why we use time, how we get to talking about 3:30 and how we count, why we count different ways. We're going to be talking about counting across cultures and especially about Mayan math and why I think Mayan math is great. And also I'm going to argue why I like grouping things in groups of 12 when I count. So most of us, when we were in elementary school, maybe in kindergarten, maybe even in preschool, we started counting, right? We went 1, 2, 3, 4, 5. And some classrooms that I've been in, every day a teacher adds a new counting stick, right, to the group. And when she gets to 10, she groups them together and puts them aside and keeps making groups of 10. And if you come to the Headwaters Science Center, our Peggy, who's kind of our master counter here, she keeps us organized. When she has $10, she paper clips them together to keep them organized. So when she counts them, they're ready to be counted by 10, right? We also have pennies, and then we count them up to get, when we get 100, we use $1, right? Sometimes we have to go to the bank and get money. So when we're counting things, how do we organize them? So if I just have a whole bunch of, I wanted to use something else besides these sticks, but if I just have a whole bunch of something and I throw them down, how can you tell how many there are? Ryan, do you have a guess? I don't have an audience here. What would you do to figure out how many there are?
With that many, I'd probably count them one by one.
You count them one by one, right? Yeah, so sometimes we organize. If there's more, then we make them into groups, right? So it's hard for us. If there's just a few of things, we can look and you can see, Ryan, can you see how many of those are without counting?
Yeah, 4.
Right. But throughout time, people have organized numbers in different ways to keep track of them, especially before they were calculators. So the numbers that we normally use every day here in Minnesota, we call them, when I was in elementary school, we called them the Arabic numerals, right? Our teacher always said a word, I thought it was kind of a strange word, numerals. So what is a numeral and what is a number, first of all? So numbers are ideas, and a numeral is just a fancy way to say that you're writing down the number. So we used to call them Arabic numbers, but really they were developed by Hindu people and by other people. Different cultures come together and changing and exchanging ideas, and that's really a great way to have numbers and have number systems that you can trade and that you can share ideas. So the numbers, we're not going to talk about them very much, but the numbers that we use every day, right? There are 10 different digits, right? There's a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? There's 9 of them, and then plus the 0, which was added later. And we sometimes count with our fingers, right? So most people in the United States, we count 1, 2, 3, 4, and 5, right? We go 6, 7, 8, 9, 10. Is that how you learn how to count? Yeah. So I used to work, I also teach German, and my colleague once, he told me his grandma, when he came to Ellis Island, they wrote down the wrong age in the paperwork, because he got there and someone said, how old are you? And he said he held up fingers like this, and he was 3. But the person working at Ellis Island thought he was 2 because he just looked at these fingers. Okay, so Europeans from Western Europe tend to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way, right? And yeah, so are there other ways people count with their hands? Or is anybody out watching this do American Sign Language? There's a counting system for American Sign Language, but I knew it once, but I don't remember it.
An interesting spin is I was in wrestling in high school, and I would referee for the younger kids, and when we count to 3 in wrestling,
Oh, 1, 2, 3.
pinky, ring finger, middle finger. So it's 2 with the pinky and ring, and then 3 as the middle in it too. So you go from the side. And,
oh, you go this way in, yeah. So it is a cultural thing. Chinese counting is also really cool. And maybe I'll even show you the visual from my computer. But it's E-R, sun, just like in English, right? And then C, Wu, and maybe you can see this. Can you see this?
oh yeah, that shows.
That shows?
Yep.
Okay. So maybe so let's start over again. We have E, R, sun, C, she, I mean. Can you see it's a shape here? And then Wu, you can kind of see it's a similar shape. And then for 6, it looks like kind of like the same as the character, the way. So in Chinese, they write with characters. It's kind of like our words, our parts of words. There's kind of like a picture of the words. So we call that characters.
And so it's all done with just one hand.
It's all done with just one hand, yep. So you can do up to 10 with just one hand. And there's different regional and cultural varieties too. So I just wanted to show you that.
Cool.
And Japanese people, a lot of Japanese people, will actually be the opposite. Well, they'll start off with this is 0, and then each finger you put down is counting. So there's different ways, so just make sure that you are on the same system that other people are using. And let's talk about another system that we have. When I tell time, okay, I brought my clock here. It's just a little bit after 3:30. Okay. How is our clock divided up? There we have a morning and a night, and the AM is 12 hours, and the PM is 12 hours, right, to make 24 hours. And each hour is divided up into 60 minutes. Why do we do that? Why do we have 12 hours times 2? There's a lot of cultural reasons, but I also think it makes sense because you can take 12 and you can divide it in half, you can divide it in quarters, you can divide it in thirds, and you can divide it in sixths. So to me, that makes a lot of sense, right? So for example, if I made you a beautiful pie like this, and I said, let's share this, okay? How could you make it even? It's hard to do by tens, isn't it? So if I want to make it even, I can just fold it in half, right? Okay? And I can fold it in half again, right? And then in half again. I keep folding it in half, and I do not have an exact circle because real life is not exact. But here, I can kind of get my 12 parts of my pie. And so I think for me that's a much more logical way to organize than trying to divide something that either a circle or maybe a rectangle into 10 even parts, right?
It's interesting that there's, at least as far as I've ever known, not like a base 10 clock at all. Like they do it with there's a metric like everything except for time. Except for time,
right. And I think it's just because it's easier for us to think about. If we have a line, decimal system works great when you're thinking in a line, right? Because you can just keep going and keep going, so adding 10. But I think what we often do when we're thinking in a circle, like an hour or a day, or the world, right? When we navigate longitude and latitude, we also use 360. And there's close to 360 days in a year, not quite. And different cultures have come up with ways to compensate that and figure that out. But I think that it works to think you're kind of going around a whole year, right? In about 360, give and take a little bit. So I think, to me, that's why it makes sense to think about when I'm turning around, or when I'm using a compass or a protractor. I brought my protractor, but I don't see it, right? When we measure angles, we also go with a circle being 360 degrees, right? So if I do a right angle, that's a part of it. And I think that's because it just makes sense to think about parts of a whole using using multiples of 12, right? Which gets us up to 360 instead of by 100s. Yeah, have you ever measured angles metrically and based? No, huh?
No.
No, right? So if someone out there has other arguments and reasons for that, let me know. But I just think linearly, counting to 10 and keeping going seems to work. Now, I'm going to teach you a way of doing math, which I think makes sense. So before we had calculators, let's talk about Roman numerals first of all, right? So we do one, and we use these. Actually, we use one of these elements at the Science Center. Right now, I've been counting the group size here. We make tally marks, right? We go, so we can count by fives. When someone comes in, maybe there's a group of 3 who comes in. Then maybe we have 3 more, right? 1, 2, 3. And maybe then there's 5 people come in. So I go 1, 2, 3, 4, 5. We do tally marks. What does that look like? Then we can count them by fives. It looks like this, right? So that's kind of like based on a human body. So we can remember that we can count by fives. So Roman numerals are kind of based like this. And we could do a whole nother thing about Roman numerals. But what happens with Roman numerals? Right?
They turn into letters.
They turn into letters, right? And they get to be very long. And I also have a hard time keeping track of them. Even though I've talked about them a lot, I have to even look on my chart.
The order of them gets
for the order of them, right?
Sometimes for
right. So maybe we can show my fancy little chart here. Maybe we can give everyone a quiz here. Can you see that again? I'm sorry that this is not. This maybe is better than the projector, actually, huh?
Probably.
So you can see here, right? These are how we do Roman numerals. And at different times, actually, Roman numerals have been different. So we had M, right? That's how to do 2016. Says that one below, right? Can you figure out how to do 2020?
It would just be.
So, right, we got 2000.
It'd be the MM.
Right?
XX, is that it?
I think so. MM, yep. It doesn't really matter which one we did, right? So we see them in a few things.
What about 2021?
Right, 2021, and we just add a 1. Right?
Or would it be MMIX?
I think it's MM. I don't think it actually matters. And I need help with it. So I think it's on the end. 16. I think we add it on the end. But that gets kind of confusing, right?
Yeah.
We use it for things like the Super Bowl. Does anybody remember one year the Super Bowl did not use Roman numerals? What Super Bowl were we on, like 54? I'm not a big.
Yeah, we're
over
probably
50,
approaching
right?
60 at this point.
Okay, but Super Bowl 50 did not use Roman numerals. Anybody have a? I have an opinion why. I'll show you how you do 50 in Roman numerals, and you tell me what your opinion is. What year? So that is Roman numeral 50, right? So I guess nobody wanted that on their Super Bowl ring having an L there, right?
Yeah.
That seems like the English word for losing. All right. So now we're going to travel to the west, actually south of here, to the Western Hemisphere, and we're going to talk about what I think is the most elegant numeral system, counting system, much more elegant than what the Romans used. And this is also based on the human body. And it goes like this. This is what people in Guatemala and in Mexico, in Central America, the Mayan culture, what they invented. And then it hasn't been used for very long, but now kids in the Yucatan Peninsula are learning this in school again. And so you have to have your body, not just your hands, but also your feet for this. So we have 1, it's just like this, 2, 3, 4, and now we're gonna run out, right, our fingers. So we count 5 like this. So I'll show you how to do that. You can use beans and sticks. So I have here my little gems. So you can do 1, 2, 3, 4, and now instead of 4, So instead of adding a fifth bead, we add a stick. Okay, so that's 5. We'll do that again. 1, 2, 3, 4, and 5. Now I can use my other hand, right? 6, 7, 8, 9, 10. So add another stick, right? And then I also have my toes, right? So I can add, I could add this, but then I run out, I can't add any more. So what do? What can I do?
Bunch them up again.
I bunch them up again, right? And I'm gonna move over here since I don't have any other guests here and show you this chart here of how with using Mayan numbers, we can get very big numbers very easily, okay? So what they did, or what they still do now, is they had a shell, okay? And a shell, an empty shell or an empty basket to represent nothing, right? To represent, well, actually something important, 0, or kind of a placeholder. So you can put a placeholder, okay, the shell here, in the ones. That's showing up okay, Ryan? Mm-hmm. And then, okay, if I place one gem, one bean, one pebble, one counter, and number in the 20s, I have 20. Okay? So if I wanted to do 21, I take away my 0 shell, and I add another one here. So there's 21, right? 22, 23, 24, and now what do I need to do?
A stick.
I get a stick. So I put down my stick, right? So I have 20, 5, 26, 27, 28, 29, and now I need to put this here, and now I have 20, 25, 30, 31, 32, 33, 34, right? 35. Okay? Got it? 35, 36, 37, 38, 39. Now what do I do? Oops. We can leave that. We might not get to the bigger numbers. Okay? We might have to have another.
We're not going to count 1 by 1 to 400?
Well, I don't know if we can get all the way to 4. I just want to show you that when we do this, first of all, we have multiplied by 1, then by 200, and then by 20, then we multiply 20 by 20, which gets up to 400, and then we do 400 by 400, which the next one will be 8,000, okay? And there's an adjustment too for doing dates, because what is weird about Earth? We have this weird thing where it takes us, right? It takes us 365 and a quarter rotations, right, to get around the sun. So that is kind of a weird thing about living on planet Earth. So then we can put, right, we can't put this here because we can't add any more. So we would then get rid of these and represent 40 this way.
And once you got to 4 pebbles in your 20 spots, it would become a stick too?
Right. So if I had, 20, 40, oh, hold on. We need to have our placeholder, right? So we can keep track of where those are. So 20, 40, 60, 80, right? How many 20s? And so that would be 100, okay? 100, 200, 300, 400. Okay?
Well, no, that's not 400.
No, it's not 400. It's 20, 200. This is where my linear math is not working. So this is 20. 5 20s is 100.
Yep.
And then that's another 5 20. 200.
300.
300.
But then on the fourth one, you got to move up to your
Oh yeah,
box.
fourth one we have to move up to our box. Yep. So then we have our 400 is here. Oh, thank you.
You have to put a shell in the 20 spot.
And then we have to put a shell in the 20 spot. Okay?
So that's 400 really.
That's 400. Mm-hmm. And we could keep counting and keep going up. Thank you, Ryan. But I want to show you one thing that I like about this. As you can see, I'm going to have Ryan here because sometimes I have a hard time adding and subtracting in my head and keeping track of numbers. And this is really good for people like me and people who are learning how to work with numbers to work with them. So for example, I can add numbers. So if I have, let's say I have 3 items represented here, and I have another item here, and I can add them up, right? Maybe I'll put it over here. I should have had a third spot to do that. How do I add these numbers together? It's very easy, right? I just count them. 1, 2, 3, 4. Okay, so I could put my four beans here. 1, 2, 3, 4. Okay? Now, what if I have something more complex? Okay? What if I have, let's say I have, again, how much this is? So I have 5, 10, 11, 12, 13, right? 13 plus, let's say 3. How do I do that? Okay, I can put them all together, right? Let's just say I'm going to put them all together over here. And then what do I need to do?
Combine.
I'm combining these, right?
Yeah.
So I need to trade these 4 in for a stick, right? And so how many do I still have? There's 2, right? So, no.
You got to trade 5 in for a stick.
5 in for a stick. 1, 2, 3, 4.
So you got 1 too many there.
1 too many. There we go. It's usually easier when you're not presenting to a group out there, so that you can add them together like that. Okay, we can try another one with subtracting. But and when you get to bigger numbers, actually you can manipulate them. You can keep grouping and regrouping them. So that you can keep track, instead of keeping track in your mind of all the numbers, you can use these to represent the places. So you can.
This is something that, like, obviously we do in our everyday life too. Like, I was counting the change in the register this morning, and I don't count the quarters individually. I put them in groups of 4 and then count them by the dollar.
Right,
doing
right.
the same thing.
Right. So we group and regroup numbers in order to manage them, right? Yeah. Should we do any more? Anyone watching that has a request for a number?
Can we do 2021 in this?
20. We'll do that. We'll do 2021. We'll do 2021. Which, if you would like to learn more on your own and explore more on your own, I really recommend reading about Mayan numbers and Mayan calendars, because they regrouped again, right, to get the year 360. So Mayans have a different system of counting the years. And I think they just started over recently. So
yeah, that's what all the like 2012 apocalypse stuff was based on. That people were worried about was there was like a turnover in the Mayan calendar cycle. Right.
Just like when we changed the millennium in our Western calendar, we were worried things are gonna explode too. So 2000, right? So how many 400s we have? We need 400, right? Another 400 is 800. Another 400 is 1,200.
Uh-oh, we need another box up there.
We need another box up there, right? So we can add another box. And what that other box would be is how many 800s. So I'm using purple for that.
It would be,
8,000s.
Yeah.
We don't need another box for that because it's number 400s. That's 8,000. We don't need it.
8,000 or is it 200? Or 2,000? 400 times 400.
Yeah,
okay.
Right? 4 times, it's 8,000, isn't it? This is why I do this with like numbers up to 400 is about all I can do. So 400 plus 400, that's 800, and that's 1600, right?
Yep.
Okay.
And so can you put...
Then we have to add 20s, right?
Can you put another... Oh, yeah. Okay.
Yeah, because we're going by 20s.
Yeah.
Because we don't need to add 400
So you
more.
gotta come up with 200 more in 20s, yeah, you're right.
Mm-hmm. So here we have, we can maybe represent this using our Roman numerals here. Thank you, Ryan. So we have 400, 800. Two groups of 800 is 1,600. Right?
Yep.
And now, how many more do we need to get 2,000? We need
400 more.
400 more. Right.
Are we sure it doesn't bump up to 2,000 for the next level? Is it 400 times 20 that we got to do instead of 400 times
20? Oh, it's 400. Yeah, it's 400 times 20. 400 times 20, which is 8,000. 8,000. Yeah, so it's times 20. How do we do this? Maybe this is what I need to figure out and come back to. There is a Mayan numeral conversion website that you can look at. And again, this is what we like to do. Why I like to do these presentations, because it forces me to think and learn and do stuff. And while we are looking this up, I will make a short announcement about our schedule. So until the school year is about ending here in northern Minnesota. So from now until June 4th, we're going to be open Mondays, Fridays, and Saturdays from 9:30 to 5 o'clock, and Sundays from 1 until 5 p.m. And then on the midweek, Tuesday, Wednesday, and Thursday, we're open only for school groups. We have just a few places left. If you have a group that you would like to come, or any kind of group, it doesn't necessarily have to be a school group, but we're trying to have just one group at a time, so we can make sure we can clean between groups. But then starting June 4th, we'll be open to the public 7 days a week. So similar hours, but open to public 7 days a week. All right, Ryan, what is the result? Guess I could have looked it up too.
Still working on it.
All right.
I think this is exactly what I'm looking for. I think this is like a calendar one.
So while we're looking at that, I just want to show you. There is there are replicas, or there's actually original numbers in Mayan language, and I can't remember what the language is called, that you can see. And the best preserved one is actually in Dresden, in Germany. Let me find a picture of that for you. While we're looking here. It's called the Codex Dresdenis. Here. Is it? Oh, sorry for the dead air, everybody. I had it ready. I had it loaded up. Do you have it?
So the tricky part here is I keep finding examples that are using the calendar version, and so there's a difference with the calendar version and the standard counting version, where instead of having a 400s place, they have a 360 place.
Right, that's where when we get to the Earth is kind of weird, and the number of days it takes to go around the moon, around the sun. But I just wanted to show you. Maybe I'll come around so I can hold close to the camera. This is what. I've an ancient text, and I should know the years, but I don't. But what they look like in real, in usage here, where you can see. And I think this is actually like a multiplication table
I know where
here.
we're messing up here.
Where are we messing up, Ryan?
We are. So this isn't 400, 800.
Oh, because you're multiplying 400s. Yeah. This is
We're using sticks instead of beans.
Oh, now he does. Yes. Oh, of course, Ryan. This is why having. So now we have 400. This is 1,600. Whew.
So if it's one stick, gets us to 2,000.
One stick gets us to 2,000. All right, and now we have 2,400, 2,800, 2,000. What are we here? Actually, 2,000. Where are we?
We're trying to get 2021.
Right. So 2,000. This is 2,000 and 20 and 1.
There it is.
So if you can see, if you were as practiced at this as kids who learned this system well, you can see that actually this is a really elegant way of writing 2021 with just three symbols, right?
Good looking out, chatter. Thanks for that.
What?
There was somebody in chat that pointed that out.
Oh, thank you, all those out in the chat.
Because I was trying to figure out, because it's like every word.
I know, I was looking at it, but I think if we had followed the pattern, the way, right, with carefully counting, with using the beans and then the sticks, we would have made sense to us. All right, I think my brain is busy. And I'll think about one more way, since you're all joining us on the internet, another number system that works great if you want to only have two choices, right? A yes or a no, a 0 or a 1, and that is, of course, what is that system called, Ryan?
Binary.
The binary system, right? And that's very important for coding. And that works great. It's not very elegant if you have to, for like writing on paper, because they take up a lot of room. But it's great if you want two choices. All right. Well, thank you very much, everyone. I'd love to hear your comments. And also your ways. How do you count? What are things that you do to help you organize the numbers that you work? Have any of you ever used a slide rule or an abacus or other counting systems to help you? All right. Thank you. And I will hope to see lots of you come and visit us live or give us some good comments.